Jarek, the floor is yours.
Thank you, Alexander. So, just a second. Well, now you should see my slides, and my presentation is about overheating in modern apartment buildings in Estonia. This study assessed the compliance with summer thermal comfort in new apartment buildings according to Estonian regulation, which sets overheating requirements based on the temperature simulations which are needed to be run as a part of EPC calculation. And so we did temperature simulations for quite many apartments and quite many buildings, and we also conducted field measurements to see how severe these problems are in the buildings. So I have first some introductory slides about these Estonian requirements. So in Estonian regulation, it is said that the temperature limit is 27, and there is a fixed calculation procedure. According to that, you should run a simulation, and in between June 1st and August 31st, the temperature excess hours cannot be more than 150 degree days. How this will be calculated, I will discuss later. And 27 has been set as a limit temperature for residential buildings, so it means that it's some sort of flexible limit because accepted excess is 150 degree hours. And this Estonian procedure is the following. So it's a part of energy calculation, typically done for the building permit documentation. And there is one specific form of summertime temperatures to be filled. And this will be done together when all this energy performance certificate input data is filled and output data, so the results of the energy calculation would be reported, and it needs to be a part of a building permit application. So this is simulation-based approach, and in Estonian regulation there are also some requirements for the simulation tools. But basically these are nothing special when we speak about developed tools. So all validated commercial simulation tools basically can be used, both for the energy simulation and both for the temperature simulation. So calculation rules are defined. For example, window airing can be taken into account with some limitations, like that only the windows need to be in the opening positions, and wind-induced flows are not accounted, but only buoyancy-driven flows are accounted. And what happens if somebody will not comply with requirements? Actually, there are no sanctions yet applied in Estonian practice. But the logic is that if the requirements are not met, then the problems needs to be fixed. And regarding this overheating issue, indeed the occupants will complain and made reclamations for the developers, and it has been also a practice to install some shading devices, or maybe even more commonly some cooling devices to fix the problem. So these kind of problems have been existing in reality. A couple of words about the calculation procedure. So as I told, this is a simulation-based approach, and standard use of a building is defined in the regulation. Here you can see there are profiles for lighting, equipment, occupancy, and also values for these as loads of internal heat gains. And also the climate test reference year is given and defined, and this Estonian test reference year, you can see that in the winter it's quite close to -20, not exactly, and in the summertime it's quite close to 30, but still keeps below 30 degrees. And this figure shows the solar radiation. So this needs to be used to run an hourly simulation for critical rooms. Here you can see some examples of these buildings and a selection of rooms which will be most probably overheated, and the same as a building model in the simulation software, or another building here with some modeled rooms. So it's typical that the rooms with the highest windows facing south or west and no solar shading would be most easily overheated. So in our study we had 25 new apartment buildings. Basically all of these were randomly selected, and only criteria was that these were newly built ones. We simulated 158 dwellings to find out the most critical ones, and 16 dwellings was measured for a period of 3 months in the summer last year. To describe these buildings, it needs to be said that most of them were massive buildings, so having quite a remarkable thermal mass, which will indeed help when the passive measures for the like ventilative cooling and so on would be applied. Thermal insulation level indeed is quite good in modern buildings, and window G values also were within quite a wide range, as you can see from here. So in the modeling, it's important that windows are correctly modeled, and actually this data was checked from the site, and as well as compared to the design documentations, but we tried to use actual windows installed, and this was carefully modeled in the simulation software to have a correct properties of the glazings. So window airing is taken into account in this calculation procedure for the residential buildings, and it means that the windows can be in the opening position, in the airing position. As you can see from this figure, you need to estimate what's the opening area, and to model this in the software. And you also need to make some sort of control of opening of the window, in this case by a small thermostat, what will open the window when it is too hot indoors and still outdoor temperature is lower, so that there is some ventilative cooling potential, and windows are needed to be closed when it will get too cold indoors. So this kind of logic needs to be in the simulation software, and this can limit indeed selection of the software, because all tools do not have such sophisticated modeling features. But basically it is possible to model also without window opening, but when temperatures will be higher, and in some cases difference can be quite a significant one. So when the simulation will be run, this is an example of the temperature results, and basically all these hours and excess values over 27 degrees will be accounted, so that we can see here temperature excess over 27 as this red area, and the calculation is actually quite simple. If hourly simulated values are available, so it means that excess value over 27 is calculated. In this period, you can see marked with red from 12 o'clock until 5 o'clock. It will make, it's just a sum, it will make 4.2 degree hours excess over 27 degrees, and this will need to calculate for the full calculation period set in the regulation from 1st of June to the end of August. So it's quite straightforward procedure, and now we are coming to the results. First of all, this summer it was quite hot. As you can see, duration curve of outdoor temperature 2014 compared to the test reference year, so it was significantly more hot weather during this summer, and it can be expected that overheating problems were quite severe because of such a heat waves. Especially in July, we can see many periods where the temperature was quite high compared to the test reference year, which is representing just a common representative summer. And this means that measured results and calculated results cannot be directly compared because of different weather data. And the procedure indeed is based on the temperature simulation. But measurement results indeed can provide additional value, and we will see what are the temperatures in the reality and how many complaints we will have and so on. This is one example how these data lockers were installed so that they were protected from direct solar radiation and were kept for 3 months in each apartment measured. So measurement results from all apartments you can see from this graph, and it can be seen that the temperature was quite high at the end of July and beginning of August. This black bold curve shows some sort of average value of all measured apartments, and we can see the excess over 27 limit, let's say during 1 month almost continuously. One reason because of this hot summer, and indeed most likely these solar protection measures and passion measures applied were not enough as another reason. Then we also calculated these excess hours as a degree hours over 27 for all measured dwellings, and we can see much higher values than the limit value to be used in the simulations, 150. So only one apartment was below and the second one was quite close to that limit what applies for the test reference year and for the temperature simulation procedure. So during that warm summer there happened quite a lot of overheating in almost of all apartments. And when we assess the compliance, when we need to rely on simulated results, and these show that there was a number of buildings which were below requirement of 150 degree hours, but actually 17 out of 25, so 68% did not comply. So all these having a higher values than this red threshold line of 150 degree hours. So compliance was not good, and you can see that a couple of buildings were quite close, and when the deviation is after that is quite high. So it can be said that about half of the buildings were quite close to comply with this requirement, and half of the buildings had quite massive excess compared to the requirement. But the truth is that according to the procedure, 68% of them did not comply with the regulation. So not very good results in that respect. And to conclude, it is important to understand that measured and simulated results cannot be directly compared because of different weather data, and also because of window airing can be taken into account in the temperature simulations. And when you run the measurements, and for example apartment is an empty one, when the window airing will not happen, and the result will be somewhat different. So that's the reason the compliance assessments needs to be done based on the temperature simulations. But indeed, these measurement results confirmed that high temperatures over 27 degrees did exist also in reality, and actually in majority of these buildings measured for remarkable portion of the measured period, indicating high risk of overheating. And our researchers, they indeed received many complaints from the occupants, but we did not systematically collect data on complaints and how severe these problems were, because we know that when the temperature is higher than 27, it really is quite hot and people will complain. This has been proven in previous studies, and as a thermal comfort criteria, this limit value has been set to the regulation. So it was not the aim to study how relevant this criteria is, but we just studied the compliance to this criterion. So the main conclusion was that 17 out of 25 did not comply with the requirement, so showing that this requirement needs really to be taken more seriously, and more careful temperature simulations will be needed in the design phase, and indeed necessary passive measures like a window airing and solar shading, size of the windows and so on, balconies should be applied to fulfill with this requirement. And actually it is quite a new requirement since given 2012, so it is have been in practice only for the last 3 years, so it is not a big surprise that in many cases the requirement was not yet met. That concludes my presentation, and I will give it over to Alexander. Thank you very much for listening.